Welcome to Doozer Shop. Let me just get right into the update for you, show you what I've been working on. Kind of got sidetracked with a few little projects, but I'll show you what it's all about, and then we'll get on to more fun stuff next time, I guarantee it. Alright, first things first, I got to show you an update on the Colchester 17 lathe. So I took off the carriage in preparation for getting, I got my bushings made, preparation for getting this thing back together. It's in pretty good shape. One thing I wanted to show you guys. The oil is fed from, this is the bottom side, so it's fed from the top side with spring-loaded ball oilers there and there, okay? And the balls were completely gone, and these passages, it's about two inches thick, were completely full of chips and grease and gunge. Yeah, it was horrible how much grease and gunge and chips. So this thing was not receiving lubrication, and the felt, I got new felt here, or roll of felt. The end, where the way wipers, they were not on here. There were no way wipers at all, and if there were way wipers, they have 1024 threaded holes to mount them, but there were none. So I'm gonna basically, the project at hand is to make some aluminum way wiper holders and put a piece of felt in there. I got this felt. It's 1/8 thick and 5/8 of an inch wide. I was just talking to my buddy Jim on the phone, Jim C, and he's like, "Oh, you should use 1/4 inch felt." And I said, "Well, I can double this up." And he's like, "Yeah, that'd be okay. Just hold more oil." So I got to make 2V type out of aluminum, way wiper blocks, and 2 just flat ones. And I'm going to mill out pockets for the felt, and then I'm going to put flip top oilers on the way protectors, so it'll oil the felt and it'll distribute the oil. I'll put a brand new ball oiler. I got some from McMaster Carr in the top side, but I plan to primarily use the way wipers to distribute the oil, to apply the oil and get the felts lubricated, and it'll wick all the oil onto the ways. So that's in the works, and I've been cleaning. I got this cleaned. It's got a flat file all over everything. Made sure it's all flat. Kind of chamfered the holes with a deburring tool. So this is clean, and it's gonna have the oilers put in it. I gotta make the blocks. I'll just bolt I'll drill the holes, I'll bolt the blocks on, and I'll just scribe my line to mill the V to the line. It's the most accurate way. And after I'm done, I'll actually drill the holes tight for the bolts, screws, and then drill them a little oversized so I get some movement. So that's that, making way wiper blocks for the felt, for the Colchester 17-inch carriage. Still got to get back on the facing head, the summit facing head for the Giddings and Lewis horizontal boring mill. Okay, so this is actually a Clausing Colchester. The Clausing Colchesters for the American market had hardened bedways. This lathe is in very good condition. I'm happy to say. One thing that I noticed happened from all the chips being packed in the carriage is this. Let me go on this side because it's easier to film. I don't know how the camera's picking it up. I know there's shadows. So this was a gouge in the ways. Okay, I know people are going to leave comments and controversy and whatever. So what I did is I filled this gouge in. You can see it when I get the shadow just right, with solder, with 6040 rosin core electronic solder. And I didn't film it because I hate editing videos, but what I did is I used 2 propane torches. And I cleaned it with lacquer thinner. I cleaned it using a brass wire brush. I cleaned it with lacquer thinner and a brass wire brush about 3 times. Then I applied flux to it, rosin flux. And folks, rosin flux is in a petroleum jelly base, and that's what carries the rosins. So that's basically what it is: petroleum jelly and rosin, which is the cleaning agent for the steel or the copper, the metal you're going to solder. So I know I'm going to buy a new camera, and this one's not really a great camera to pick this up. But what I did is I had 2 flames, torches, blowing this way, blowing this way. It took about 10 minutes, maybe 15 minutes to get it hot. And then after applying the flux, and then I wire brushed it and cleaned it and applied more flux, wire brushed it, lacquer thinnered it, and fluxed it a 3rd time, being sure not to melt the flux, and being sure not to burn the flux. I started putting solder on, and the solder initially would ball up, and then when the bed was hot enough, it would wet out. So it went from I guess what would be adhesive to itself to cohesive and spread out. I think I said that right. And another thing I did is I used a scraper, a machinist scribe. Let me go get it. Yeah, like a little scriber. And what I did is once I got the solder molten and it was spreading out, I put the tip of this, and there's still hard solder on there, in the scratch, in the gouge, and I would work it back and forth in the molten solder, work the puddle back and forth. And the heat from the flame would heat up the scriber, and actually I had, I clipped some vice grips on here, and I had a leather glove to keep the heat away. And the flame would transfer the heat into the scriber and help transmit heat into the solder. And I was riding that scratch back and forth, applying heat to the bed, to the scriber, into the solder, and this is really adhered in there well. It bonded, and I didn't want to get the oxyacetylene torch because these are hardened ways, and I didn't want to risk softening anything. I know you'd have to turn it brown or blue or straw, but so just kind of wanted to tell you guys, you can use soft solder, and the only thing I wanted to do was prevent chips and grunge from collecting in that gouge, scratch, whatever you want to call it, and getting under the carriage. So the way wipers, the felt has a nice smooth surface. I know I talked this to death, but I'm quite proud of being able to do this with the solder, and hopefully give some of you guys an idea of what is possible to fix things. But other than that scratch, this bed is in fine shape. Like I said, pardon the camera, but I'm very happy with the condition of this bed. And it's interesting, the Colchester has a V and a V and a flat and a flat. So the inner is for the tailstock, and then the carriage runs on the outer. A lot of lathes have a V, a flat, a V, and a flat. And I guess it doesn't matter, but this one happens to have the two flats on the back and the two V's on the front. As a side note, I will show you, okay, the Hendy Tool and Gauge Maker lathe, talking about architecture of machine tools. So the tailstock runs on an inner V. It's a 45-degree V on both sides. So the tailstock is in here, and the carriage runs on a V and a V. This is kind of an older style that lathes were built to. So the carriage on the Hendy Tool and Gauge Maker lathe, the carriage rides on this V and this V, and the tailstock runs on this inner V. Whereas the Colchester, 17-inch Colchester, has a V and a V. So the carriage runs on the V and the flat, and the tailstock also runs on a V and a flat. So just a little bit of difference in architecture. The Harding HLVH is an inverted dovetail. I don't think I have any other lathes in here. Yeah, whatever. Okay, what else was I going to show you guys? I have, oh, yeah, I got the sprockets for the Gorton project, so I'm going to be putting a sprocket on there, and I had to buy a taper pin reamer because this used to be on there, and I'm replacing this collar with a sprocket, and then another sprocket is going to go on bearings in here. So that's coming up. That's watch this space, folks. I got some parts. And okay, now tripping over stuff. My buddy Jonathan W. He brought me, my friend Brad delivered his piston. It's from a 1928 Franklin, and I'm going to be welding up the top ringland with my TIG welder. You know, I think I'm going to let Jonathan remachine it. But yeah, this is 1928 Franklin air-cooled inline 6. I'm going to try and help my buddy Jonathan W. out. Jonathan does a lot of cool videos of hot rod and automotive restoration. I'm soaking this in lacquer thinner. Jonathan's a hands-on guy, and I'm going to try and help him out with this restoration on this piston. That should be the next video this weekend. I'm going to prep this, clean it, TIG weld it, and give it back to Jonathan for his 1928 Franklin. I like the Franklin, made in Syracuse, New York, and I'm from New York State, Buffalo, and that's going to be a cool project I'm going to showcase for you guys. Other things than that I've been working on. Let's see, my bandsaw, I took it apart. Okay, rigid bandsaw. It's actually made by Emerson Electric, made in USA. This is my project. The cylinder, the feed rate cylinder, it used to be on the back. Yeah, can't show you guys. Okay, so it was mounted to that bracket and that bracket, and it was in the way of the vise. And not in the way, but it was right underneath the vise. There's the counterbalance spring. But I couldn't reach the, it was a pain to reach the valve. So what I did is I made this bracket for the pivot on top. Yeah. And I made a bracket for the pivot on the bottom. And you know what? It flexes. It works well. Everything's great. Now, I'll get into some details a little bit later. But what it does, it flexes the bottom. I can kind of show you. Let me tighten that up. show you. There. Am I looking at the right thing? Can't tell what I'm looking at. Oh, okay. Alright, so let me do it. Lifting it up. See that flex? The camera's stationary, and basically that foot is flexing. So I gotta put maybe a box tubing inside there, inside the leg, because it's hollow inside here, and it's only like less than 1/8 inch plate steel. So that's what I'm up against. Is now that I got this cool mount for my hydraulic rate control cylinder, my mounting foot flexes. So I'm going to be making some reinforcement, either 2-inch angle or 2-inch box tubing, and I'm going to put it inside to beef that up. So watch this space, folks. Until next time, this has been the update from Doozer Shop.